Alright, so in the last video we took a look at how you could model vacations as Java classes. So in this one, let's have a little bit more fun. It's going to be pretty similar. Hopefully you find it at least a little bit similar. Let's have a little bit of fun and get in the Halloween spirit and look at modeling some monsters. So let's read through what exactly we've got to do, and then we'll hit the ground running. So, let's get into the Halloween spirit with this example. Write a full monster class that contains the following: an instance variable for the name of the monster, give us some examples there. An instance variable for the type of the monster, once again there's some examples there. And an instance variable that represents the scariness of the monster, from like a scale of 0 to 10. We're going to need a no argument constructor, and that's going to give us a random name and a random monster type. And we're going to need that parameterized constructor so that we can actually create monsters. So we're going to need that parameterized constructor that's actually going to let us provide what sort of monster we want to make, and the type of monster that it is, and also how scary that monster is. And then lastly, we're going to need those methods. We're going to have the getter methods and the setter methods. So let's dive in. Let's make our file. So here's the doc string. The author is me, Mr. Stoneacre. The date is still 10/30/20. And the file is going to be called monster.java. Cool. So, class monster. And inside of here, so we've made our class. Let's go ahead and save it. Cool. And actually, let's build a tester first. So, we should be able to make a monster. Right? So that should work. And we should be able to print out, because we're going to take baby steps. We should be able to print out m.name. Just copy this. m.type and m.scary rank. Scary rating. Scariness rank rating. Yeah, we'll call it the scariness rating. Okay. So we should be able to print out all of those things. So that's the bare minimum of what we want to do right now. Save it, compile it, we're going to get an error, doesn't exist. Alright, cool. So we'll go over here, we're going to make those instance variables. Name, type, scariness rating. And what type are these things? That's a string, int. Compile, go back to the tester, run, null, and 0. So those are the defaults. So without us providing anything, a monster's name is going to be the null pointer. We're going to get in trouble with that probably. Watch this. Let's see. His name is... I have a feeling that's going to throw an error. Oh, okay. Anyway, his name is null. That's not something you want, as it can cause errors in different contexts. Anyway. See, his type is also null. And this one's not too bad. The default is 0, and that's okay, I guess. So what we could do under here is do m.name equals Draculae, m.type equals vampire, because of course it does, and m.scariness rating equals 4. And we'll compile it, and we'll run it, And there we go. Now we're not getting those nulls anymore. But as was the case with the house example, this isn't exactly how you want to do things. Look, it took 4 lines to do it. This isn't very secure, so we can do better. So let's go ahead and make the parameterized constructor first. So monster, it needs the name, it needs the type, and it needs the scariness rating. It's going to be a public method. Everyone can see it. The name is a string. The monster type is a string. The scariness rating is an int. Just do this dot name equals name. Semicolon. This dot type equals type. This dot scariness rating equals scariness rating. So we're setting this to that, this to that, and this to that. So let's save it, go to the tester, put this into here. Get rid of that. Compile it, no errors, run it, and there we go. The exact same effect, but this is so much nicer. So there we go. We got the first 3 of these done. We skipped over the no argument constructor, but we've done the parameterized constructor. So let's go ahead and go back and do the no argument constructor. So this is the one where we're going to provide those defaults. So the original defaults were null, null, and 0. So I mean, you could include those again, but I don't know why you would. And the instructions say that we should provide a random monster name and a random monster type, as well as a random scary ranking. So what we're going to do is, let's just do this the kind of lazy way for now, because we can't get any sort of really interesting randomness unless we use a list. So we're going to use math.random. We'll just have 2 options like we did with the vacation example. If math.random is greater than 0.5, we're going to do something. Otherwise, we're going to do something else. So there's the skeleton. Inside of here, let's just do name equals Bob, type equals mummy, and scariness rating equals 2. He's not a very scary dude. I mean, with a name like Bob, who can blame him? Name equals Lena. And for those of you that weren't in class on, let's see, Wednesday, Alina was the name that got randomly generated when we were doing this by like an online random generator, and she's going to be a Yeti. That was also a monster that we had randomly generated for us. Whoops. So I'm going to go ahead and use it again. And I don't know, let's say that she's like an 8. She's pretty spooky. So we're going to compile it. Let's go back over here. It's not the dream vacation, right here. Get rid of that. So it's always good to have like an expectation of what should happen in your code before you run it. So I know that what I want to happen is Elena should print, Yeti should print, and then 8 should print. It was 8, right? Yeah. So that's what I'm expecting. So if I get that, then I know all is well. And if I don't, well then I know that I have a problem. So we compiled it, we run it. I guess we didn't compile it. We compiled it, we run it. Bob, mummy, 2. Well, yeah, because I guess it was a 50-50 shot. Let's go ahead and run it again. Okay, there we go. So yeah, this is working as expected. So now we've got our constructors done. We've done both of them. So let's do those methods. So go to the tester. We're going to have a method called getName. Oops. We're going to have a method called getType. And a method called get, oops, scariness rating. And those methods are going to do exactly what they say they're going to do. They're going to get those things. They're getter methods. Public get name. Get name is going to return a string, so public string get name takes no arguments, and it returns name. Pretty simple. Public string get type. Return type. Public, be careful, you're going to put int here, and then we got this huge long name. Get scariness rating. Scariness rating. Compile it. No errors. Go to the tester. Run. And it still works. So good. Now we've got our getter methods. Now let's do the setter methods. Public. Void, because they're not going to return anything. Remember, a getter method should return and never mutate, and a mutator method should mutate and never return. These two things should be kept separate. That way, when people are using your class, they're not surprised. What would happen if you went up to an ATM or something like that, and you pushed a button called Get Money in Account, and it showed you how much money was in your account. But then you clicked it again, and every time you clicked it, your account had $10 less in it, but for some reason it was changing what was in your account. You wouldn't want that. That's counterintuitive. It's confusing. So getter methods are like a window. They let you see inside. And the setter methods, the mutator methods, they're actually changing the state. So void set name. It's going to take a string, and that string is going to be called name. And we're going to say this dot name equals name. Copy, paste, modify. Set type. 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 Copy, paste, modify. Set scariness rating. Takes an int. Scariness rating. Scariness rating. Scariness rating. So let's go over here. Copy this. And let's test those methods. Alright, so m dot set name Brian. M dot set type brain in a jar. M dot set scariness rating 1. So that's what we should see print. Brian, brain in a jar 1. So we save it, we compile it, and we run it. So originally the monster's name was Elena. She was a Yeti. She was pretty scary. But then we changed her, and she became Brian. And Brian is a brain, and he's got a scariness of 1. He's not very spooky. Okay. So that's it. This solves the problem. And just like with the last example, there's more that you could do. You could always build on this. For example, it says that the scariness rating has to be between 0 and 10. So you could increase the randomness up here and have it actually pick a random number between 0 and 10, so it's different every time. You could do that. In fact, that might be a nice thing to add. Also down here, what you could do is say if scariness rating, and that's this one here. And you could put like new type, new name, like we did with the Dream Vacation. That would be fine too if that would help you. So if this scariness rating, so let's say is less than 0, or if the scariness rating is greater than 10, we should throw an error. And we'll learn how to throw errors. They're called exceptions later. This is not how you'd want to do it, because this would be like a silent error. It wouldn't do the mutation. Well, now it wouldn't do the mutation, but it wouldn't crash the program either. Ideally, we'd want to crash the program there. That way, whoever was using our code would know that they did something wrong. But there we go. So let's just test that real quick. Let's set him to like a -5. Like, he's gone past being not spooky, and now he's looking like he's friendly or something. So we compile it, semicolon, compile it. Okay. Go to tester, run, and you see it didn't do anything. Ideally, it would have crashed, like I said before, because we did a massive no-no. Like, obviously, we want this to be like 1 or 0 or something, because we set it to -5, but it's still at 8. But it did tell us, hey, that's not right. And then let's say we made it super spooky. Compile it, run it, and yeah, you see, he didn't do it. He started as 2 because he was Bob, and he stayed 2. So in this case, we probably wanted to set it to 10. But we didn't. And I mean, that's something you could do over here too, and just be like, hey, if it's less than 0, set it to 0. If it's more than 10, set it to 10. And I'll leave that as an exercise to you. If you want to do that, go for it. But I think we'll leave it here. This is about all that we need. Well, this is definitely all we need for the problem, and a little bit more. And hopefully all this made sense. Hopefully you could see the connections between this one and the Dream Vacation. And there's another one that's on Google Classroom now for making a song class. So give that one a shot, and hopefully you find that it's very similar to these last two that we've done. Alright, I'll see you in the next video.